Hello all. Today in this video lecture we will see engineering mechanics concept. So first we will read this. Engineering mechanics, it is the branch of mechanics which deals with the study of behavior of rigid bodies. Under the action of applied forces when they are at rest or in motion. So understand this definition. It is the branch of mechanics which deals with the study of behavior of rigid bodies under the action of applied forces when they are at rest or in motion. So, in this engineering mechanics subject, we will study behavior of rigid bodies under the action of applied forces when they are at rest or in motion. So, see this word rigid bodies. So, what is meaning of that word? Rigid bodies. That rigid body is nothing but a see definition. A rigid body is the body in which the distance between the particles constituting the body does not change under the action of applied forces. So see for that, if this is some body and this is one particle of that body and this is one particle of that body. So particle, that means it is infinitely small part of that body. So a rigid body is the body in which the distance between the particles constituting the body does not change the action of applied forces. If we applied forces like that here, so distance between these two particles does not change. This will be as it is. So this is meaning of that rigid body word. So, and this is idealized concept. There is no body or material in the universe which is 100% rigid. So all materials used in engineering like steel, concrete do suffer some deformation, but to small change overall dimension of the body. So remember that the body can be considered as rigid if the deformation of the body is very small and has no effect on the equilibrium or motion of the body. So that is meaning of that rigid body word under the action of applied forces when it is rest or in motion. So this word motion, what is meaning of that word? Motion meaning is like if an object continuously changes its position is said to be in motion. That means it is continuously changes its position. If object is here at t is equal to 0 time and after some time t is equal to 5 seconds it is here, so it changes its position. So that is meaning of that word motion. So remember that it is the branch of mechanics which deals with the study of behavior of rigid bodies under the action of applied forces when they are at rest or in motion. So see, I told you in our previous lecture that branch of mechanics. So we had studied that mechanics, that means study of matter, that is divided into solid mechanics and fluid mechanics. Solid mechanics is nothing but the study of solids and fluid mechanics is nothing but the study of fluids. And that solid mechanics is further subdivided into engineering mechanics and deformable bodies. Engineering mechanics, that means study of rigid bodies, and deformable bodies, that means strength of material subject, that is study of elastic bodies, and other is plastic theory, is study of plastic bodies. So remember that things. So this next bullet point is engineering mechanics is subdivided into two parts. One is statics, other is dynamics. So what is statics and what is dynamics? So statics is nothing but it is the branch of engineering mechanics which deals with the study of behavior of rigid bodies under the action of applied forces when they are at rest. So this word is important here, rest. Difference between the definition of statics and dynamics is this word only. See, it is the branch of engineering mechanics which deals with the study of behavior of rigid bodies under the action of applied forces when they are in motion. See here in dynamics, that body is in motion, and in statics body is in rest, and others are like applied forces and that study of behavior of rigid bodies, those are similar. So statics, that means it is the branch of engineering mechanics which deals with the study of behavior of rigid bodies under the action of applied forces when they are at rest. And dynamics, that means it is the branch of engineering mechanics which deals with the study of behavior of rigid bodies under the action of applied forces when they are in motion. So that rigid body is similar, that applied forces are also similar concept here in statics and dynamics. But remember that dynamics is further subdivided into two parts, kinematics and kinetics. And now what is kinematics and kinetics? Kinematics is nothing but it is the branch of dynamics. This is branch of dynamics which deals with the behavior of bodies considering the forces causing the motion. See, here they are considering that forces causing the motion. So that means they are interested in knowing how the body is moving, but also why it is moving. Due to some might be due to some forces it is moving. That's why they are interested in that. So remember that things. Kinematics is nothing but it is the branch of dynamics which deals with the behavior of bodies without considering the forces causing the motion. Without, see, without, that means they are not, see here, not word is important, and without. So kinematics, that means it is the branch of dynamics which deals with the behavior of bodies without considering the forces causing the motion. See, if some body is here at t is equal to 0 distance and now it is move in motion and moves here at 5 seconds. So in kinematics we are only interested in body is moving, how it is, how the body is moving, but not why it is moving. Yes, we are not interested in force here. So kinematics deals with the motion parameters like displacement, velocity, acceleration, time. So I will tell you this meticulously, what is displacement, velocity, acceleration and time. So remember that kinematics is the branch of dynamics which deals with the behavior of bodies without considering the forces causing the motion. So that is important, without considering the forces causing the motion. So that, see, that force is not here. Remember that. And kinetics is the also the branch of dynamics which deals with the study of behavior of bodies by considering the forces causing the motion. So here we will see how body is moving and why it is moving, what is force acting on this body. So this force is important here. So in kinematics we are not only interested in knowing how the body is moving but also why it is moving. So see that engineering mechanics is divided into statics and dynamics. And we had seen definition of statics. See, at rest. So type here rest and in motion. Study of that body with the applied forces and when it is at rest. In dynamics, that means study of that body is in motion. It may be applied may not be applied forces. See, because it is subdivided into two parts. One is kinematics and one is kinetics. Kinematics, that means without considering force. Study without considering force, and kinetics, that means with considering force. So that is it, and now we will see that kinematics deals with the motion parameters like displacement, velocity, acceleration, time. So what are those parameters? So for that, first see displacement. Displacement. See, displacement is a vector quantity. Vector, that means it has magnitude and direction. And displacement is a vector quantity representing the change in position of an object. So see, represent that displacement represent change in position of an object. Defined as the shortest distance between its initial and final points, including direction. So, see, displacement is a vector quantity representing change in position of an object defined as the shortest distance between its initial and final points, including direction. So, for that, see that one example. See, this is initial point, and body moves like this. So, see, this is initial point, and this is final point. Body moves like this. So, displacement is the vector quantity representing the change in position of an object defined as the shortest distance between its initial and final points, including direction. So, see, what is shortest distance between initial and final point? This, including its direction. That means it has magnitude and direction also. It is vector quantity. So, see, displacement is defined as the change in position of an object. See, initially this is at here and finally this is at here. So that position changed. So it is a vector quantity. It has direction and magnitude. It is represented as an arrow. See, this is arrow. It is represented as an arrow that points from the starting position to the final position. See, this is starting position and this is final position. That means arrow is pointing towards that final position. Displacement can be 0, can be positive and can be negative. So it is nothing but that, see, that point, distance covered plus direction, and unit of that displacement is meter, kilometer. Those are SI unit. See, if we notify this as delta x, what will happen? If we notify this displacement as delta x, and that initially it is at x is equal to, let us consider this as x is equal to xi, and finally it is at x is equal to xf. So that displacement delta x is nothing but that xf minus xi. This xf minus this xi. This is displacement delta x. So now next is concept is distance. So what is distance? In our day-to-day life, we are discussing that we covered 1 kilometer distance. Today morning I covered 1 kilometer distance, like that we are discussing. So what is meaning of that distance word? Now see, technically distance is the total movement of an object without any regard to direction. So that is total movement, how much it moved, total movement. That means if we see here on our that figure, so this is the cursor of pen, that this is distance, total movement. We can define distance as how much ground an object has covered despite its starting or ending point, total distance covered. Let us understand this concept with the help of that following. See diagram. If I would move like this is, let us assume this as A, B, C, D, and this is 4 meter, this is 3.5 meter, and this is 4.1 meter. So distance formula is this 4 plus 3.5 plus 4.1. So this is delta D. 4 plus 3.5 plus 4.1. So the complete length of the path between any 2 points is called as distance. See, it is complete length. Distance is scalar quantity. Remember that. It is 11.6 meter. Distance is 11.6 meter for that. 4 plus 3.5 plus 4.1. Scalar quantity, that means it is like it only has magnitude. It don't have that direction, only magnitude. See here in this formula we are not bothered about that magnitude, the direction, sorry. We had only considered magnitude. So only magnitude consider in this scalar quantity. That means, and so distance is a scalar quantity as it depends upon the magnitude and not the direction. Remember that, not direction, not direction. That means this scalar word is telling this all. Distance can only have positive values. And the unit of that distance is SI unit, meter, kilometer. Okay. Now next is speed. See, also that speed is also we are using our day-to-day life. Speed, which speed is nothing but the distance upon time. So it tells how fast an object moves. How fast an object moves. And see, it is also scalar quantity. See, with respect to time, it is like important that this distance is nothing but See, unit distance unit is meter and time unit is seconds. So unit is meter per second, either kilometer per hour, like that. So this time is important factor here in speed. So due to that time, we are able to understand that how fast an object is moving. So it is scalar quantity. It is also only in that also we are only considering that magnitude and not the direction. So that is about speed. Next is velocity. So that this is important concept, velocity. So see, the term velocity give us an idea how fast or slow an object is moving. How fast an object is moving. So this velocity tells us that idea. See, difference between speed and velocity. Speed also tells us how fast an object is moving, but it is distance upon time, and that velocity is nothing but the velocity is displacement upon time. That is difference between both of them. That means velocity is vector quantity. It is defined as the rate of change of displacement. So quite often we come across situations where we need to identify like which of the two bodies move objects in moving faster. That means see, if this is A and this is B and those both are moving, so quite often we come across situations where we need to identify which of these two objects are moving faster, either A is moving faster or either B. So then due to that reason we need this velocity. So see, one can easily tell the fastest of the two if they are moving in the same direction. Like A is also moving in same direction, B is also moving in same direction. Then we will know which is faster. But see, however, if this direction of motion is in the opposite direction, then it is difficult to determine the fastest. If this A is moving in this direction, then it is difficult to determine which is fastest, either A or either B. So in such cases, the concept of velocity is helpful. So it is defined as the rate of change or displacement. Velocity is nothing but a displacement upon time, and SI unit is like meter per second and kilometer per hour. And it is directed speed. See, directed speed. See this word. Directed, that means vector quantity. Speed is only scalar quantity. Speed has only magnitude, but directed speed, that means it is velocity and it is vector quantity. So this velocity also be zero, negative, positive, because see, this displacement also be zero, negative, positive due to that. So it is also defined as the distance traveled by moving body in a particular direction. Particular direction, that word is important, per unit time. Distance traveled by the moving body in a particular direction per unit time is called as velocity. Now next is acceleration. See, speed unit and velocity units are same, but only definition is change. Only that scalar and vector is different between that. See, acceleration. So what is acceleration? Acceleration is the vector, representing how fast and in what direction an object velocity is changing. So, see definition. So that is it. It is a vector representing how fast and in which direction an object velocity is changing. So it is nothing but it is denoted as a bar is equal to change in velocity divided by change in time. So acceleration is the time rate of change of velocity. So see equation. See acceleration equation. See this one car and this is that same car. After time t, it is here in this position. So this is initial position, and this is C here. If one is here hitting, and this is final position. So this car moves like this. So initial velocity is vi, and initial time is ti, and here initial velocity is v up and final time is t up. So that acceleration is nothing but the change in velocity. So how this velocity change? Initially this car is here and finally it is here. So v up minus vi, it is changed velocity. Change in velocity, and change in time is t up minus ti. Final time minus initial time. So that is acceleration, change in velocity divided by change in time. So this acceleration in physics refers to the rate at which an object velocity changes over a specific period of time. So it measures how quickly an object speed increases and decreases. Acceleration, how quickly an object speed increases or decreases. Acceleration can occur in various directions. So remember that it is vector quantity, and unit of that acceleration is, see, velocity unit is kilonewton per meter, and time is, let us consider in, wait for a second, that velocity unit. See that velocity unit, what is velocity unit? It is meter per second. See, meter per second. So meter per second divided by second time, so it is meter per second square, unit of that velocity, SI unit. So by that way we had covered our basic engineering mechanics concept. So see that engineering mechanics that are divided into statics and dynamics. Statics, that means it is nothing but rest. Dynamics, motion. Kinematics, that means without considering force. Kinetics, consider force. Engineering mechanics is divided into statics and dynamics. Dynamics subdivided into kinematics and kinetics. Kinematics, that means without considering force, and kinetics, that means considering force. See difference between word. KINETICS. Only in between these this EMA comes. So that is C. Displacement is a vector. It represents change in position of an object. So we will see this displacement concept in our structural analysis subject. So this displacement is a serviceable word. So it is very important in our structural design. So remember that thing. That distance is a scalar quantity. It won't see that speed is a distance upon time, tells how fast an object moves. It is also scalar quantity. Speed. Velocity is also how fast an object is moving, but it is vector quantity. It is displacement upon time. Acceleration is vector, and it is also how fast and in which direction an object velocity is changing. That means it how quickly an object speed increases or decreases. So what is vector and scalar? That is also very basic important. Vector and scalar. Vector, that means it has magnitude and direction. See 5 meter. See, let us consider this as this is, yeah, north, east, west, south, and this is a 5 meter. So it is 5 meter towards east. That is vector. That means it has direction also, and it has magnitude also. This 5 is magnitude, meter, 5 meter is magnitude, and towards east is direction. Scalar only has magnitude. It is only 5 meter. We don't know we don't know about direction in scalar. So remember that things. So we will conclude our session here. Thank you very much.